Here we're going to determine the factored form of the polynomial and list the zeros. So first things first, we got to think about our factoring toolset. What are all the ways that we can factor a polynomial? And my last tool that I'll want to use is actually the rational root theorem and kind of plugging in and guessing and checking. So first thing here that I know about is that if I have a greatest common factor, I can factor that out. If I have a quadratic, I know how to factor quadratics. We also have some special cases like the difference of squares, the difference of cubes, and the sum of cubes. And lastly, we have this idea of factoring by grouping. So basically, we always want to keep these in the back of our mind to double check to see if we can use them to help us. Especially in this situation, when I look at this, I actually see that there is a greatest common factor of each of these terms, which is 2. So what that means is I'm going to go ahead and clear this, keep this in mind here. But what I'm going to factor out is 2, which leaves me with x to the power of 4 minus x to the power of 3 minus 2x. Sorry about that, that's 2x minus 4. So what that leaves me with is 2 x to the power of 4 minus x cubed minus 2x minus 4. So now we look at this piece here and we go through our factoring tool set, none of which actually really helps us. So now we got to move on to the rational root theorem and plugging in things using synthetic substitution. Got to be really careful here when we are substituting these back in, because what we should notice here is there's actually a missing degree here because we're starting with power to the 4, then power of 3, then we're missing x to the power of 2. So I'll show you what that means in just a little bit here. But first of all, possible rational roots are going to be the factors of the constant, which is just 1, 2, and 4. And then we put that over our factors of our leading coefficient, which is now just 1, so we don't really have to worry about that. So all of our possible rational roots here are positive or negative 1, 2, and 4. So here's the deal. Now when we're plugging this in, I'm going to start with 1 because I like to start with my easy numbers first. And again, I'm using this new polynomial that I've created over here. I have to go down in descending order. So here's my power of 4, my power of 3, and since I don't have an x squared, I have to have a 0 here, or else it'll mess up my equation here. And then I have negative 2, because that's my x to the power of 1, and then my constant. So now that I have this set up, we can go ahead and start plugging this in and seeing which one gives us a 0. So this one here gives us negative 6, so that's not going to help us. Let's go ahead and try negative 1. Okay, and now when I plug in negative 1, that gives me a 0, so I can factor out x plus 1 from this polynomial, because I know if I plug in negative 1, that's going to give me 0. And what I'm left with here is x to the power of 3 minus 2x squared plus 2, plus 2x minus 4. So now I'm going to continue on. Let's look at this really quick. No greatest common factor that I can take out. It's not a quadratic. Maybe factor by grouping, but yeah, let's try factor by grouping here real quick. First of all, let's change colors so that I don't mix it up here. If I were to factor by grouping, I can look at this as x to the power of 3 minus 2x squared, and then 2x minus 4. So on the left side here, I can actually factor out x squared from both sides, and I get x minus 2. And then on this one here, I can factor out a factor of 2, which gives me x minus 2 also. Now, because I have the same factor here, x minus 2 and x minus 2, I can take that out, which gives me x squared plus 2 and x minus 2. And so I get x plus 1 times x squared plus 2 times x minus 2. If we wanted to, we could have plugged in, positive 2 in here, and what you would have seen with this string of numbers here, negative 2, positive 2, and negative 4, is that these would have actually canceled out here and given me a 0 anyways. So again, you could have continued to use this, but I used factored by grouping because that's in my factoring tool set. So either way, you're going to get this as our factored form. And then we want to list the zeros. So the zeros here are going to be -1, +2. And then this one here, I'm actually going to do this in a different color to make sure that we can see it. If I were to figure out what the zeros were, x squared plus 2 equals 0. I'm subtracting 2 from both sides. I get x squared equals -2. And now we got to worry about the square root of a negative number. This is actually going to give me x equals plus or minus the square root of -2, which is the same thing as plus or minus square root of 2i, because I know that if we are square root of a negative number, then that gives me I, imaginary. So my final answers here for the polynomial is x plus 1 times x squared plus 2 times x minus 2, and my zeros are -1, plus or minus the square root of 2i, and +2.